Quantum is not 100 years in the future, it is now. If you're looking for a future, quantum will be something that out of 3 jobs, only 1 job is being filled. That's a good opportunity for the kids in all different levels.
As part of RQS's outreach to introduce what quantum is to middle school and high school students, 3 grad students and an undergrad developed the Quantum Activity Kit. First, it was initially brainstorming the ideas, what are the concepts that we want to teach them, while using things that they would interact with in their everyday lives. And we also wanted it to be something that they could take home, because most of the physics experiments are things that are done with the help of a teacher and then you just don't see them ever again. And we wanted kids to be able to take this with them, explain to their grandma what this is that they learn at school. After multiple iterations and collaborating with the design team, who are all engineering students, we came up with the final version of the activity kit. The 2 quantum concepts that we introduced through this kit are superposition and measurement. We know, at least in quantum, it's widely believed that making a measurement, for instance, clicking a photograph is making a measurement, observing something is making a measurement. The very act of measurement changes the inherent properties of the quantum system. And we also know that quantum systems can exist in multiple states at the same time, where you can be in 2 different positions at the same time, and that's what is superposition. They're very fundamental to quantum physics, but also something that they can experience in their everyday lives using sunglasses. And instead of sunglasses, we use polarizing filters in the activity kit, and we were able to demonstrate 2 very fundamental quantum concepts.
One of the big important things here, especially through the K through 12, is training the teachers and making them feel comfortable. All of them walk out like, I can do this. I can see where we can place it into our curriculum to show our kids why you want to go into this field. By using these kits in polarization, we use classical experiments of how polarization works, and then we take the next step in talking about the quantization of that and looking at different states, superposition. The teachers are very comfortable because they know it from the classical sense, move into the quantum sense, and they have a hands-on activity that they can actually show their students. The second part of the experiment is doing particle wave duality, because again, we're talking about light, and let them know that this is just 2 of the concepts that we can get with our young people, that hopefully by the time they get to the 12th grade, that they're looking at the field of quantum in itself.
I hope that they at least understand the basic terminologies. For example, what superposition is, what that means, what a qubit means, what entanglement means, because these are concepts that are abstract. And I also hope that they understand the different quantum gates and how particles move through these gates and how that's different from a classical computer to a quantum computer.
With University of Maryland taking a lead by reaching out and say, we really want to make sure that all of our students here in Maryland is going to really participate and understand quantum is where we're at, and we're open and inclusive to everybody.